Welcome to solverfy.
This is the answer to Chapter 15, problem number 63 from the Smith Organic Chemistry textbook. And this problem says devise a synthesis of each target compound from the indicated starting material. And we're told we can use any other required organic or inorganic reagents. So for A, we're trying to get to this alkyne from an alkane. And so the first thing that we're going to have to do, since we're starting with an alkane, is going to be to install a handle or a functionality that we can work with to affect the transformation that we want. And so radical bromination is going to be a good way to do that. It's going to selectively brominate this secondary carbon. Okay, and then so from here, what we can do is treat this with potassium tert butoxide. And that's going to get us to the alkene. And then we can take our alkene and install two bromines by just using bromine, elemental bromine. And then now we can use a strong base. So again, we could use potassium tert butoxide. We could use sodium amide. So let's do that. NaNH2, 2 equivalents, and that is going to get us to our alkene, or pardon me, to our alkyne. Okay, so there we go. There's A. So then for B, we are told to start from this molecule. So we already have bromine in here, so that's good. We have some functionality that we can work with. And so we'll start with potassium tert butoxide, and that will get us to our alkene. And then to get to our final product, we can use HBr under radical conditions. So with peroxide, and that gets us to our product. Remember, if we were to just use HBr, we would be right back at our starting material, but those peroxide conditions allow us to add it in an anti-Markovnikov fashion and get to our final product there. So then for C, we're starting from acetylene, and we're trying to get to bromobutane. And so we're starting from 2 carbons and ending with 4. And we're starting with acetylene. So an easy thing to do is going to be to deprotonate that acetylene to an acetylide ion with sodium hydride. The acetylide ion can then act as a nucleophile, and we can use bromoethane. And now we have our 4-carbon chain that we need. And if we then treat that with H2 and Lindlar's catalyst, so H2 and Lindlar's catalyst, that's going to get us to here. Okay, and now we want to add a bromine in an anti-Markovnikov fashion. So just as we did in part B of this problem, we'll use HBr, but we'll use it with peroxide. So it'll be radical conditions, and that is going to add our bromine to the end of the chain here. And that's the molecule that we're looking for. Okay, so that's the answer to this problem. The only way to really solve this problem is to know all of your reagents from previous chapters and from this chapter, and to know how to put them to use. And that's the answer to chapter 15, problem number 63.